Hello friends, welcome to VK Lectures. In this lecture, we are discussing the question number 23 from Karnataka set 2024 physics question paper. Wave function of the particle moving in free space is psi is equal to e to the power ix plus 2 e to the power minus ikx. So psi is equal to e to the power ikx plus 2 e to the power minus ikx. Now this is the wave function. Find the probability current density to the real part of the wave function. Now probability current density J is equal to h cross by 2im into psi star del psi minus psi del psi star. Okay. Now let's find out what are these quantities. Now if the question is the probability current density to the real part of the wave function, real part of the wave function do not contribute to J, that is the current density, so it will be equal to 0. But let us find out what is the current density for this wave function. Once again, the real part of the wave function do not contribute to J, so it will be equal to 0. Now let us see, this wave function has imaginary part. So for the imaginary part, what is the current density? So for that, let us write down what is the given quantities. We need psi, which is equal to e to the power ikx plus 2 e to the power minus ikx then del psi equal to e to the power ikx times ik plus 2 e to the power minus ikx times minus ik. Now psi star, the complex conjugate of psi, will be equal to e to the power minus ikx plus 2 e to the power plus ikx. Del psi star will be equal to e to the power minus ikx times minus ik plus 2 e to the power ikx times ik. So what we need psi star del psi, which is equal to, psi star is here, del psi is here. So e to the power minus ikx plus 2 e to the power ikx times ik can be taken out into e to the power ikx minus 2 e to the power minus ikx. So that will be equal to ik into e to the power ikx times ikx, that is 1, plus e to the power ikx times minus 2 e to the power minus ikx. So minus 2 e to the power minus 2 ikx, when 2 and 2, that is plus 2 e to the power 2 ikx, 2 e to the power ikx and minus 2 e to the power ikx, that is minus 4. Okay. Now we need psi del psi star, that's equal to psi del psi star. So e to the power ikx plus 2 e to the power minus ikx times del psi star is equal to again ik into minus e to the power minus ikx plus 2 e to the power ikx. So that's equal to ik, we can again take it out, e to the power ikx times minus e to the power minus ikx, that is minus 1 plus e to the power ikx times 2 e to the power ikx, that is 2 e to the power 2 ikx, then 2 e to the power minus ikx minus, so minus 2 e to the power minus 2 ikx again plus 4. Now what we need is del sorry psi star del psi minus psi del psi star, which is equal to subtract this and this. So 1 minus of this, so let's use, so this is the first term and the second term, so add a minus to it, so minus, so this becomes plus, this becomes minus, this becomes plus, and again this becomes minus. So 1 minus, so here you have minus 2 e to the power minus 2 ikx, this quantity and this quantity gets cancelled. Similarly 2 e to the power 2 ikx and minus 2 e to the power 2 ikx gets cancelled, and here you have 1 minus 4, which is minus 3, and here 1 minus 4 again minus 3. So what you have is ik times minus 3 minus 3, that is minus 6, and by the formula you have to divide it by h cross by 2im, so 2im times h cross is the reduced Planck's constant, so h cross into psi star del psi minus psi del star, that is equal to j, so multiply by h cross divided by 2im, I and I get cancelled, so that is equal to minus 3 h cross k by m. So this is the current density J. Now for a general wave function psi which is equal to a e to the power I k x plus b e to the power minus I k x, then let's write k1x and k2x. Then the current density J can be written as h cross k1 by m times the magnitude of A, that is, this is in the positive direction, minus h cross k 2 by m into magnitude of B square. This is minus because it is in the negative x direction. This is positive because it is in the positive x direction. Okay, so we have the equation like this: psi is equal to e to the power plus I k x plus 2e to the power minus I k x. So this term is in the positive direction, the flux is in the positive direction, this is in the negative direction. So that is the current density. Current density is nothing but flux. So according to the formula, h cross k1 is nothing but k divided by m, and here we have square. Okay, so h cross k by m, magnitude of, there is a no coefficient here, so it's 1 square minus h cross k by m k2, k2 is also similar k, into b square, the coefficient, that is 2 square. So what you get is h cross k by m 1 minus 2 square, that is 4, that is minus 3. So that is equal to minus 3 h cross k by m. This is another simpler method to find the current density J.